Hey, guys, gals, and ghouls. Today we're going to finally cut some chips. So let's press forward.
I'm trying something different today. Uh, I'm going to just give you a brief summary of what we'll be discussing. Let me know in the comments section whether or not you like it. So today we'll be talking about finishing up the motor pulley, setting the correct tool height for cutting, installing the chuck, taking cuts with a brazed carbide cutter, cutting threads, and changing gears for threading.
I want you all to remember that I'm just another yokel who is not educated nor a professional in what I'm doing here, and it's possible that, if you rely on this video, you, your project, or the both of you might end up as a smoldering hunk of hammered dog shit. Please use common sense, be careful, and always protect your ears, eyes, face, body, and hands when doing this type of work. With that, let's keep on trucking. This video may contain peanuts.
Well, hey everyone, and welcome to Werner's Whirligigs, or welcome back if you've been here before. I'm Werner, and guess what? We're finally going to make some chips today with the lathe. And boy, are they delicious. You want some? Don't worry, no potatoes were harmed in the making of this video, but it may contain peanuts. So today we're going to mount up a piece of steel and start cutting it on the lathe, and then hopefully, if that goes well, we'll change around the gearing, and then we'll do some threading. The tailstock on this lathe has a clamp with a broken handle. Somehow the threads got broken off, so we're going to attempt to repair that handle and put it back on so it works. Right now there's an ugly 6 by 1.0 millimeter screw in there that just annoys me every time I see it. I don't know about you, but I hate when people do that. I like when machines look like they came from the factory. I mean, yes, I understand that sometimes you have to do what you need to do to get things done, and that's okay. But since we have a little bit of time, let's make the repair and get it back to looking like it did. Okay, I think that's all we need to do here. Oh, last thing. We're going to start the video just going over and finishing the painting of the motor pulley. That's what allows us to actually start cutting chips today. So we'll start there and move on.
All right, time to finally paint this thing up. I'm just going to start with some primer. Now it's time for the color. Anyone can tell I am not a gifted painter. It's sort of a hunt and peck approach. Here's the finished product. I think it's came out pretty nicely. It's not perfect, but I wasn't expecting it to be. Had a little bit of a run here. This is where the repair, one of the two repairs was, and you can see just a little bit of it here. And on the other side, this is where the repair was. I think it's more than good enough to keep the pulleys in there. What you're seeing here is the hole that clamps onto where the bolt or the set screw clamps onto the motor shaft. But yeah, I think this is good enough to get the job done now. I'm going to let it sit for a couple more days before I put it on, because I'm going to have to hammer on it a little bit with a wood driver to get it onto the shaft with the key on it. But that's an update. I feel like we're moving in the right direction. Pretty soon we'll be making some chips.
Well, looky here. We've got the motor pulley back on here on the left side. I mounted the pulley. I tightened down the screw that clamps onto the motor shaft, and I also put a belt on. And I used a different belt from before. You might recall that I had two belts on before. There's a belt here that goes behind this sheave back in the back and connects to this one, and then you use this pulley here to drive the main pulley, which turns the either turns the lathe or turns the mill. So I've got it set up at the lowest speed of the highest gearing, which is 630 RPM, and I suspect I'd probably be using roughly that range, 400 to 600. I have this formula that I just wrote up on the wall. RPM of the piece that you're turning is, or the desired RPM, is equal to the square feet per minute divided by the diameter of the piece that you're turning or cutting, it could be on the lathe or on the mill, times 3.82. So let's say we're turning a steel rod, and the cutting speed is 200 square surface feet per minute, and it's got a 2-inch diameter. So surface feet per minute, 200 divided by 2-inch diameter, 200 divided by 2 is 100. And then we multiply that by 3.82. Let's just do 4 to make it easy. So that would be 400 RPM. And as your piece gets bigger, your speed, the RPM gets slower, because if you have a larger diameter, the metal moving on the outside of that diameter is traveling faster. Let's give it a little bit of a workout. We now have it in at 600 RPM. Let's fire it up. We don't even have the chuck on yet, but we'll get to that. By the way, I've gone through and I've greased all the little ball fillers everywhere on the machine, and I've also done the lead screw and all the gearing in the gearbox here. Let's put it in low first. Put this in forward. And then we'll turn it on, and then we'll engage the lead screw. There we go. And you can see now it's moving. Now I'm not sure if I can move it from low to high while the machine is on. I'm just going to assume that I can't right now. So now I have it in high, and that just changes the speed at which the lead screw turns. It doesn't change the speed of the chuck at all. Probably the best way to monitor it is by looking at this. So here's your high speed, and here's your low speed. One of the first things you're going to want to do when you're setting up your lathe is you want to adjust the height of your cutting tool so that it's the same as the center height of your chuck. And we're going to mount the chuck shortly, but right now I still have the dead center sitting in the center of the spindle, and we're going to bring in the cutting tool. I've just mounted a cutting tool that came with the machine in the tool holder, and we're going to see how close it is to the top of this cutting tool is to the tip of this. So let's crank it up. And bring it in. I'll do it by hand the last little bit. And you can see, wow, that's really close. And of course it's close because this is the tool that was sitting in here when I received the machine. So it's at the right height. I don't know how big that cutter is. Probably metric. Since this stuff is metric, it looks like a 1/2 inch or 12 millimeters, something like that. Anyways, this is the right height. So now we can go ahead and put on the chuck and mount up a piece of metal, make some chips. Let's get this chuck on here. Now I think I told you quite a few videos back, that there were numbers on here to help align it when you put it back on. So well, you can't see it, but there's a 3 standing up here, and there's a 3 here on the chuck. So those two need to be lined up.
and then we can start threading in a bolt. I'll tighten them up when they're all in. So I'm not sure if you can see it, but there is a number 2 right here and a number 2 right here on the chuck. It's finally time to make some chips. So let's go ahead and start setting things up. I've got a piece of 1 1/4 inch steel. I think it is 12, what is it? 14L15 or 12L15, I forget what it's called. But anyways, we're gonna chuck this up here in this three jaw chuck. All right, then we need to set this up. I put the compound slide on here, and I just put it at it's at a random angle right now, but I want to set up this part of it, the tool holder, so that it faces this perpendicular. Well, it's parallel. Excuse me. So what I'm going to do is drive this in here. Okay, and then I'll tighten this up. Bring it back out. Just double check it here. I don't know if I spun it while I was... We'll just do it like this again. Okay. So I'm pushing it up against the piece of steel in the chuck so that I can make sure that it's aligned, the edges are aligned parallel with the piece of steel. Okay, and finally, we'll put a cutter in, and I have this cutter that came with the machine. Oops. And we tested it yesterday and determined that it sits at the same elevation as the center point of the chuck. So I was happy with that. Okay, we're all set up now. So I'm going to run this in, and I'm just going to use the lead screw and the cross slide to run the cutter right now. I'm not going to use the compound slide. I've got the lathe set up to turn at, I believe it's 600 RPM, which is probably a little bit too slow for an 1 1/4 piece. It probably should be 800 or so, but we're just taking a first pass. Yeah, I'm gonna fire it up and see what happens. This is 3/1000 of an inch. Alright, we started to get some chatter there. Couldn't tell you why. Okay, we'll try again. Maybe I'll back it off just a little bit for this first pass to 2/1000 of an inch. See what happens. Alright,
that was a little bit better. You know, it could also have to do with these bites here. This is just a piece of steel I had sitting around, and actually, you know what? It looks like it started to chatter when it started running into those bite marks from another lathe. So, okay, I don't feel so bad anymore. But let's keep it light for now. We'll just try 5/1000ths of an inch. All right, well, that was pretty exciting. It's a little bit warm, and I do see an interference pattern on here. Okay, let's back it out. And let's do another 5/1000ths pass, 5/1000ths of an inch. And then what we might do is drill in the end of it and put a tailstock, use a tailstock to hold it. So, yeah. We'll take a little bit more. We'll do 8/1000ths of an inch. We're getting the nest. But actually, it's a pretty clean cut. Try it again. Okay. That interference pattern's getting lighter and lighter. I'm going to set up for using the tailstock, so I'll stop the camera and come back. I've got a drill chuck in here now instead of the center, the live center, and in that is a center drill. I'm going to put a little dab of cutting fluid on it. That's more than a little dab. And we're going to put a hole in the end of it so we can use a live center. I've attached the live center now, and I'm just touching off here to set my 0 on the cross slide. So let's try it now. I'm not sure. Let's zoom in a little bit first. The interference pattern isn't really obvious, but we'll see. I'm just curious if this is going to make it a little bit more steady and remove the interference pattern or stop the interference pattern from occurring. So we'll just take a 5/1000ths cut and see what happens. Well, that looks pretty good. It looks better than the prior cut. Yeah, I don't really see much of a pattern now. I mean, geez, I would be happy with that cut. That's very clean. Okay. All right, let's try 15 thousandths. Yeah, that looks really good too. Step it up to 25. All right, excuse the bumping around. Whew, that's warm. Well, that actually did 45 thousandths there at the end. I was having a little difficulty getting it to come out of gear, which is where I bumped the camera. But boy, yeah, look, this 25 thousandths cut looks great, and same with the 45 thousandths. Impressive. All right, well, this is great news. Well, you know what? Following up on that success, I want to get a little wacky, let down my hair. As my mom would say, maybe I want to get a little bit zany. And so, I was thinking, what can we do? This, using a bolt as a lever, bugs the crap out of me. Or it's not a bolt, it's a threaded screw. And so I want to repair that. We have the original handle here, but you can see that the threaded part fell off or broke off or something. It has this flat here as well for turning it with a wrench. So what I propose is that first I'm going to try just to cut this back and re-thread it, and hopefully that'll work. If not, we'll turn another handle with threads on both ends. So let's give that a whirl. That handle has an M6 by 1.0 millimeter thread on it. So that means we got to come into this chart right here. Here's the 1 millimeter pitch. Follow this over. So we need 4 gears. We need a 60, a 56, a 36, and a 32. So I'm going to go round up those gears and come back. It turns out that the 60 tooth gear is already on there. So we need to take off all 4 because let's see. Yeah, we're going to swap the position of the 60 tooth gear. So let's do that. Remember now, we're working with A, B, C is behind here, and D is down here. So we don't need to touch this gear. So pull this one off. This, by the way, has 2 gears. This one seems to want to be a little bit difficult for some reason. There we go. Alright, so we'll put on D first, which is a 32 tooth gear. I think this 32 tooth gear is going to give me a little bit of problem, so I'm going to probably have to tap it on. It just doesn't want to quite go. I don't have to give it a lot of pressure or energy.
There we go, that's the 32. Okay, the B and the C is going to be a 56 and a 63. I'm sorry, a 56 and a 36. So that's this one. I feel like I'm going to have to work on this one a little bit, so I'm going to shut off the camera for a moment while I do. Okay, now we're going to slide on B and C. Okay, now we're going to actually have, don't forget, we're going to have to loosen this and line things back up again, I believe. Let's see, and then the last one is going to be the 60, which we pulled off earlier. Here we go, 60. Okay, yep, and that one's not going to go on because things aren't lined up. So let's loosen this up so this can all swing around freely. Well, I think this requires a little finesse. Get these clips back on. I already did one. It's probably not going to be good viewing. That was easier than expected. Ladies and germs, we're back again. I've got the lever or the handle mounted up in the chuck. We're going to cut this down to 6 millimeters and make a 6 by 1.0 threaded rod on the end of this larger rod, and the purpose will be to screw this handle on here. I've already practiced threads on another piece of metal, and I am pretty comfortable with how to do it with this machine. We have to leave it in gear the entire time, and when I say that, we have to have the screw attached to the motor the entire time. We can't take it out of gear because then we'll lose our timing for the threads. So the first thing I'm going to do is cut down this rod to 6 millimeters in diameter. So let's go for that. Before we start cutting the threads, I'm going to put a little landing pad in this. We're ready to cut the threads. I've got a 60-degree
brazed carbide cutter on here. While this is not a thread cutting video, I'll just tell you a little bit about what I'm doing. I've got my compound at 29.5 degrees from this angle, so it's this way, 29.5 degrees. If you don't understand that, you should go look it up. At the 0 point, my compound is zeroed, and also the cross slide is zeroed, so that when I'm here, I'm at 0, 0. That is when I'm just touching the uncut rod that will soon be threaded. So when we take a pass, every time we finish, we stop the motor. We cannot take it out of gear or it will lose its timing. So what we do is we take a pass, we stop the motor, we back out the cross slide, and then back it all, turn the motor in the reverse direction, back it up, and then put the cross slide back to 0 and turn the compound slide in about 2 thousandths. So you'll see, it's a process. Let's actually put a little bit of blue Dykem on it. Try not to get it everywhere because that stuff does not come off. We're ready for the scratch pass now. And my job is to turn it off before it crashes. Okay, so we stopped it, not taking it out of gear, put it in reverse, run it backwards, put it back and forward, put the cross slide back up to 0, and turn the compound slide in 2 thousandths, which is more like 1.7 thousandths or 17 tenths because of the cosine. All right, got it in forward, it's in gear, let's go. Okay, put it in reverse, power back out. Cross slide goes back to 0. Move the compound slide in 2 more thousandths. Put it in forward. So at the end, what I'm doing, I hit off, but then I'm also backing out the cross slide so that it doesn't crash. So I've reversed it. All right, 2 thousandths. Forward. See, all it takes is to forget one thing. I forgot to put it in forward. It's okay, I didn't hurt anything, but it'll crash it. We're going to give it a try with the nut already. Not yet. Wasn't expecting it to, but it's worth trying. Alright, let's zoom out now so you can see the steps I'm taking. Okay, lathe in forward, 0 on the cross slide. This has been turned in 2 thousandths on the compound. Let's go. And I'm armed and ready to shut it off. Bring it back in to 0, add 2 more thousandths, put it in forward, go. Put it back into 0 on the cross slide, turn it into thousandths. Forward, go. Okay, so reverse, run it back. All right, back into 0. Forward, turn it into more thousandths. I'm out by an entire turn on the cross slide. Which was 40 thousandths. Okay, let's try it again. Forward. Let's try the nut again. We're getting there. We're getting close. Reverse. Go backwards. Zoom you back in. You know, actually, I think we're done. I zoomed you in for nothing. Ta-da! All right, let's check it out. Here's the handle. It has 2 different sized threads on it. Well, these are the ones we just cut. So we'll put this one in here. Actually, does it fit the other way? It does. Fits both ways. They're both. I could have sworn when I checked it earlier they had different threads. Yeah, that's what I thought. This one doesn't go in here, but this one, bizarre. It likes these new threads better for some reason. Okay. And there we go. Now we don't have to stick this ugly thing in there anymore. Okay, I'm satisfied now that the lathe works. I think it's good to go. The last thing that we're going to work on, and I think it'll be in the next video, is putting the mill on and setting it up. So, fantastic. Well, everybody, it's that sad time of the video where things come to an end. I'm sure you'll survive without me. I don't know if I'll survive without you. This was a fun way to wrap up the lathe. I was really impressed by the way it cut. People say that this is a really good lathe, but I'd never gotten to use it before, and I really liked it. And you know, changing over the gears and using it to cut some threads, that was pretty fun too, and it worked well again. So good for you. You're a good lathe. Good boy. Yeah, so if you enjoyed the video, give me a thumbs up if you don't mind. I'd appreciate it. If you didn't like the video, that same thumbs up button, you wouldn't believe it, but it's also a middle finger button. So if you didn't like the video, you just give me a thumbs up, middle finger button, and call it a day. We're not done with this piece yet. We still need to put the mill drill up on top, and we'll get to that in the next video. I guess, and speaking of next videos, you know, if you want to subscribe, please do. I don't know that it helps numbers or anything, but I do release videos 3 times a month on the 1st, the 11th, and the 21st. So, Just there will be a stream of content coming in the future. I guess we'll wrap it up here, and we'll see you on the next one. Thank you again. I really appreciate your company, and if you've watched this far, thank you. So long for now.